Next, I invite you to strap on your seatbelts and get ready for a series of MPC application quick pitches. The goal here is to give you an introduction to some of the many different applications where MPC is playing a principal role in facilitating privacy and/or security for production deployments today. This will be a series of short 5-minute back-to-back presentations, so get ready. I believe we're going to start off with Dr. Benjamin Case reviewing the application of MPC in building the future of ads. Ben?
Well, I thought that was a great overview we just heard by Nigel on MPC versus other privacy-enhancing technologies. My name is Benjamin Case, and I'm excited to kick off this hour of quick-fire MPC application pitches by sharing with you how MPC is being used to transform the future of personalized advertising at Facebook. The ads ecosystem today is evolving due to an increased demand for privacy and more regulation. At Facebook, we believe that keeping people's information safe has to come before anything else. We also care deeply about enabling the best advertising experience, which means connecting people to the products and services that they will love and allowing businesses to measure the impact of their Facebook ads. That's why, alongside academics, global organizations, and developers, we're investing in a multi-year effort to build solutions using privacy-enhancing technologies like multi-party computation. These technologies will help us minimize the amount of personal information we process while still allowing advertisers to reach relevant audiences and measure ad effectiveness. As our industry evolves to become less reliant on individual third-party data, these technologies will be an essential foundation for digital advertising in the future, demonstrating that personalization and privacy don't need to be at odds. Traditionally, ad reporting or model training for personalization requires at least one party to learn which specific people made a purchase after seeing a specific ad. Say, for example, that a publisher like Facebook has information about who saw an ad, and an advertiser has information about who made a purchase on their website for the corresponding ad. Traditionally, those data sets would need to be directly shared to enable measuring the ad's performance. But MPC makes it possible for both parties to learn insights about how the ad is performing without the need to entrust a single party with both data sets. In a minute, I will play a video that will give a high-level overview of one example of how MPC systems can support the advertising ecosystem. To summarize the technical approach, we first use a private set intersection protocol to join or align the databases held by two different parties, and then use general purpose MPC to compute statistics on the data of those joined users. I would invite you to come by our sponsor booth here on the conference website to find out more. And now I'll play the video for us. Thank you.
Privacy-enhancing technologies can minimize the amount of data collected and processed to help protect personal information. Here's how one of those technologies, multi-party computation, can help Facebook keep ads relevant and protect the personal information of people like Nella. Nella sees a watch that's perfect for her, and she buys it. Facebook records the ad Nella clicked, and the seller, Runware, records her purchase. Meanwhile, Larissa, a marketing manager at Runware, wants to know the average spend of customers like Nella who clicked her ad. In the past, this would have required at least one party to learn which people made a purchase after seeing an ad. But with multi-party computation, people's information can remain private. Here's how it can work. Facebook and Runware each create a large data set containing thousands of people's information, including Nella's. Then, they each add a secret key to encrypt their own data set, shuffle them, and then exchange their encrypted, shuffled, and unrecognizable data. They then add their own secret key to the data they received from the other party, and a new private ID is created. At this point, all personal information is unrecognizable. But because the private IDs will match, they can calculate how many ad clicks actually resulted in a purchase. Next, the technology identifies all the various purchase amounts this set of unrecognizable customers spent on their watches. That data is split into multiple pieces and is then shuffled so no piece can be tied back to its original source. Finally, the data is aggregated. The amounts are added up, and the total is divided by the number of customers. This reveals the average spent without the need for either party to see both sets of data. Larissa can now improve her marketing strategy because she knows which Facebook campaigns drove her highest sales. And Nella can be sure her personal data remains private.